Let's see the introduction between sound waves and light waves. The difference between sound waves and light waves is that the light waves are categorized as electromagnetic waves, and due to this reason, these are visible to the mortal eyes. But sound waves are mechanical waves and cannot be seen. Sound waves are incapable to travel through a vacuum, but light waves can, as they do not require any kind of means in order to travel. Sound waves. A sound wave is the pattern of disturbance caused by the amount of energy traveling through a medium such as air, water, or any other liquid or solid matter as it propagates away from the source of the sound. Sound waves are created by object vibrations and produce pressure waves. For example, a ringing cell phone. The pressure wave disturbs the particles in the surrounding medium, and those particles disturbs others next to them, and so on. The pattern of the disturbance creates outward movement in a wave pattern like seawater in the ocean. The wave carries the sound energy through the medium, usually in all directions, and less intensely as it moves further from the source. The idea that sound moves in the waves goes back to at least the 1st century BC. The Roman architect and engineer Vitruvius and the Roman philosopher Boethius each theorized that sound may move in waves. The origin of the modern study of the sound is attributed by Galileo Galilei. There are two types of sound waves, and the one is longitudinal waves and the another one is transverse waves. Longitudinal waves. A longitudinal wave is a wave in which the motion of the medium's particle is parallel to the direction of the energy transport. If you push a slightly back and forth, the coils move in a parallel fashion back and forth. Similarly, when a tuning fork is struck, the direction of the sound wave is parallel to the motion of the air particles. Transverse waves. Transverse waves move with oscillations that are perpendicular to the direction of the wave. Sound waves are not transverse waves because their oscillations are parallel to the direction of the energy transport. Among the most common examples of the transverse waves are ocean waves. Then, uses of sound waves. The uses of sound energy are something every human has experienced, as communication would have been a difficult task for us. Below are the common uses of sound energy everyone must have experienced: communication, observation, information, entertainment, and notification. Then, light waves. Light radiates from a source in waves. Each wave has two parts, an electric part and a magnetic part. That's why light is called electromagnetic radiation. Our brains interprets light wave by designing different colors to the different wavelengths. But much of the light in the universe travels with the wavelengths too short or too long for the human eye to detect. The visible portion is a very small part of the magnetic spectrum. The wavelengths are usually measured in billions of a meter, nanometers, or 10 billions of a meter, angstroms. The distance is from the peak of one wave to the peak of the next. Humans can see wavelengths from about 700 nanometer, which appears dark red, to about 400 nanometer, which appears violet. The light with short wave lengths violet carries more energy than the light with long wavelengths red. Uses of light waves. Different parts of the electromagnetic spectrum have different uses. Radio waves, radio and television. Microwaves, satellite communications and cooking food. Infrared, electrical heaters, cooking food and infrared cameras. Visible light, fiber optic communications. Ultraviolet, energy efficient lamps. Sun tanning, X-rays, medical imaging and treatments. Gamma rays, medical imaging and treatments. Then comparison of sound waves and light waves. Parameters of comparison: sound waves and light waves. Parameters of comparisons include wave type, production, medium, travel through vacuum, wavelength, and nature. Sound waves and light waves difference. Sound waves are classified as mechanical waves. Light waves. Light waves are established as electromagnetic waves. Sound waves. Sound waves are produced by oscillating particle of the medium. Light waves. Light waves are produced by oscillating charged particles of the medium. Sound waves. It needs a medium to travel. Light waves. It does not require any medium to travel. Sound waves. Sound waves are not qualified to travel through a vacuum. Light waves. Light waves can travel through a vacuum. Sound waves. Sound waves have a very long wavelength. Light waves. Light waves have a very short wavelength in comparison. Sound waves. Sound waves are longitudinal waves. Light waves. Light waves are transverse waves. Conclusion. Light waves are transverse while sound waves are longitudinal. Light waves can travel in vacuum. Sound waves require a material medium to travel and hence cannot travel in vacuum. The speed of the light in a medium is constant. Thank you.